So good morning, Android developers. My name is Guy, and I'm joined here with Parker and Kristen. We're from the Microsoft Surface Duo team. Our team is the developer experience team. We're in charge of SDKs, tools, samples, and talking to developers like yourself about large screens. And today, we want to teach you how to become more flexible with your app and how to adapt to these new form factors. But actually, before we start, we really want to acknowledge this moment that we are here in person at last after almost 3 years of not being in conferences in person. So super cool to meet developers in person. Check us out at the booth afterwards. If you have an app, come try it out on one of our devices and we'll help you identify issues and how to solve them. We're here for you. And if you don't have time here, there is, you'll see at the end, we have a Twitter handle. We are very responsive. We have a team across the world, and we really want to meet developers where they're at. So let's dig in. So you probably already have an app in Play Store. So the focus of the talk here is not for new apps. It's how to take your existing app and adapt to this new form factor. Just like when you're going to a gym and starting something new. So we're going to start with some simple tools, simple enhancement, some complex ones, and the talk is going to cover a lot of samples, codes, and tools to support you on your needs. Let's dig in. So first, what is large screens and foldables? So to simply put it, these are devices with just larger screens. It can be a dual screen like the Surface Duo. It can be one of the flip devices. It can be just a large screen tablets. And what it means for you is more real estate for you to interact with your users, more time users are in your app, more engagement in your app. And these are really tailored for productivity. So you can do things like running 2 apps side by side and many additional things. According to Google last survey, 250 million users are already running on large screens. Again, tablets, foldables, and dual screens. And actually the last OS release they did, 12L, is targeted exactly towards that. And many OEMs and device manufacturers are picking it up right now. And it's dedicated for making platform changes to make it super easy for apps to natively run on these devices without needing to do many, many changes. Let's see some of these demos. So I'm going to show a couple of demos from Microsoft. And the reason why we chose Microsoft is because many of our apps are really tailored around productivity. And people don't know it, but we have more than 80 apps in Play Store. Again, many of them are tailored for productivity. And these apps work very nicely on the Duo, of course, and on Fold, and on large screen devices. We did a lot of work to enable those. So I'm going to show 3 demos here for Microsoft apps on all these 3 devices. The first one on the right is, again, 2 apps running side by side. On the left, you have Office or Word, and on the right, you have, again, Office and Excel, 2 dedicated apps. And when they're running side by side and you have a chart, very easily, just with your pen or finger, you can drag and drop between one to the other. And we're going to show you how to do those things. On the left here, this is the Samsung Fold. And here, we have, again, 2 apps running side by side, Outlook, but it can be Gmail or any other thing. And here, Office, with all your documents. And very easily, you can just drag and drop and attach into an email. So the work we did is on both apps to support that. And just think how hard this flow is hard to achieve on a single screen device. On the center here, you see the Microsoft Duo, and again, come check it out after in the booth. And what you see here is Outlook. And here we're showing it, not 2 apps, but the app is actually spanned into both displays. And again, allowing more real estate in the app. And when we go into that mode from a single screen, Outlook automatically goes into a least view mode, least detail mode. And what it means is all your emails are on the left, and once you select one, you're going to show the detail of that email there. And again, think about your flow in the morning when you want to go and browse. 30 emails on your phone is very, very hard. You go into an email, you read it, you go back, you read it, then you reply. When you have a least view, just like least detail, just like on your Mac or PC, is much easier, and you can achieve that with large screens because, again, you have more space to show 2 panes. These are just some of the samples of things you can do. Check out these apps, and we're going to show you how to achieve those in this talk. So how do you get started? The first thing to get started is just take your app and try it out. Try it out on one of these devices, and if you don't have one, it's a good idea to ask for budget to get them, but also you can use an emulator. There is an emulator for, we're going to show it today, for the Surface Duo. There is one for the Fold. There is a native one coming from Google, integrated in Android Studio. And of course, there was one for a tablet. So just start with testing your app. Make sure that now that you have an extended canvas or a larger display, it works nicely. Check out things like device orientation. Sometimes apps are locked to a specific orientation. Make sure that when you rotate the device, it looks nicely. Make sure the aspect ratio, now that you have a larger screen, is not locked and is changing according to this new device. Then test how your device behaves when you're moving it from side to side. So for example, on the Duo or on the Fold, your app can run on one side, check it out on this side, check it on the other side. If you're using a Fold, there is an internal display and an external display. They have different aspect ratio and screen sizes, so when you close the device or open it, the app will move to a different display. Check all those things out. Then the next step is what we call the low-hanging fruit. Start thinking about user productivity. So when your app is going to run with another app side by side, because the user launched two apps, or there is a group that you can attach both in Samsung or in Duo, that once you click it, it launches two apps. Think about your app being in those interactions, and then what can your app contribute data to another app or vice versa? So consider adding drag and drop, and it's super easy, either as a drug destination or as a drug source or as a drop destination. Think about then how to use a pen or a keyboard. So this device goes very natively with a pen. So pen interactions is something that you want to add as well. And again, we have samples and documentation to show you all of these. Once you're done with this low-hanging fruit, this simple enhancement or the extended canvas, there is additional design patterns that you can try out. Again, the least detail can show you like a messaging app is very native for that. When you have two levels of contact, a two-page view is very native for a book reading. For example, we have here Kindle. Really looks like a book, and it's very easy to navigate between pages in the two-page view. A companion pane works great on video editing or photo editing, where you see the photo on one side and all the controls on the other. Or in a gaming, you can have the game on one display, and the other one, you can have extensions to the game, like a map or the controllers or these kind of things. And this is work we did, for example, in the Xbox app. You can come and see it using the companion pane. So all these are new design patterns for large screens that you can try out. There is samples for each one of them and code behind them that you can use as a starter point. And we also have a Figma design kit that you can try out, give it to your designers, and they help give wireframes and to-dos. Some helpful libraries. A couple of things. There is Jetpack Windows Manager. There is a dedicated talk that Google is also doing later today on this. It gives you the display features, the Windows metric, the folding features. Is the device in a folded state? What's the angle between it? Is there a hinge? What's the size of the hinge? Jetpack Windows Manager gives you all that support across all foldable devices and all large screens. Microsoft, we added an extension to that. It's based also on Jetpack Windows Manager, which gives you support for compose, for views, for layouts. For example, here you see the sliding pane layout that you see it sliding between differently in each one of those devices. On a tablet is 1/3, 2/3, and the Duo is half and half. And this is something that is also very easy to use with Jetpack Windows Manager. And our team did a lot of contribution to make this happen. We also want to meet developers where they are at. So if you're using either Java or Kotlin or Flutter or Web or whatever SDK you're using, we have a sample, we have an SDK and a documentation to help you get started on all these design patterns that we showed. I want to invite Kristen next to walk us through some of these demos and the code behind them. Kristen, on to you.
Introduction to large screens and foldables. For the next portion of our talk, I'm going to walk you through 3 different samples of increasing complexity. And I'd like to note that all of the samples that I'm going to show are open source and available on GitHub. So if you're curious about any of them and you want to see some more of the code, you can check it out later. We'll have all the links on the slides. So for this first sample that we have, it's just a simple e-reader, and it follows the 2-page pattern, which is one of those design patterns like I mentioned. And in this pattern, it's best used for reading or document-based apps, and it basically just aims to provide a book-like experience. So you can see here in the animation on the slide, the sample displays 2 pages of text, and then the user can swipe through them as if they were reading a book. In terms of building this sample, there was really only one main change that we had to add to make sure it looked great across all devices, and that was to calculate the padding between each page based on the properties of the current device. So this sample happens to be built in Jetpack Compose, so we use one of our own Microsoft Compose libraries to help us make this change. This library, which is called Window State, is built on top of Jetpack Window Manager, which Guy just mentions as one of the helpful libraries, and it lets you access this information in the form of a compose state. So if we look on the next slide here, you can see how the page padding, which is highlighted in orange, changes based on the device that it's running on. So on the left, we have a Surface Duo, and you can see the orange padding is as wide as the device hinge, but then on the right, we have a different foldable with a flexible display, so the fold and therefore the padding are much thinner. And if we look on a large screen device, since there is no folding feature present, there was no need to add padding, so we're just showing the 2 pages. And the code that we used to achieve this was very simple. So 2-page app content was the highest level composable in our app, and then we're passing in this fold size DP property from our Window State library and using that internally to set up the size of the padding in the layout. So this would be an example of a simpler enhancement you could make. So if we're going back to our fitness analogy here, we're warming up, we're starting to touch our toes. If we move on to the next sample, we have a nature catalog app, and this follows a different design pattern called list detail. And this is great for any apps, like I was saying, like messaging apps, or any app that has like a list, a gallery, a collection of items. And the basis of the pattern is that one pane is used to display a list, and the other shows a detailed view of a specific list item. So if we look together at the sample here, we have a gallery of different lake images in the left pane, and as we click through them, you can see that the detail view on the right updates with the picture, the lake title, and the other relevant lake information. Another cool feature of this sample is if we look here at the start, we're using a bottom navigation component, and that's because we're currently multitasking on the tablet, so the app is taking up a smaller portion of the screen. But you can see when we expand the app to full screen, we actually switch to a navigation rail component to help improve the user experience. And in terms of implementation for this sample, it was also built with Jetpack Compose, so we're using another Microsoft Compose library called 2-pane layout to help us set up this list detail pattern. And 2-pane layout is exactly what it sounds like. It's a layout that allows you to specify the content for 2 different panes, and it also helps with handling rotation and internal navigation. And the way that the pane logic works is that on foldable devices, it will split up the panes depending on where the folding feature is on the device. So this isn't always right down the middle, so we make sure to check that before setting up the panes in the layout. And then on large screen devices, by default, it will split the panes equally, so a 50-50 split. And for our nature catalog sample, that was the exact behavior that we wanted. So the code that we had to write to achieve this was very simple. You just have to make sure that 2-pane layout is the highest level composable in your app so that all the measurement is done correctly. And then we have these slots for pane 1 and pane 2 where you can pass in the appropriate content. And that will yield the result that's shown in the graphic on the slide. So pane 1 will be either on the left or the top, and then pane 2 will be on the right and the bottom. But if there are cases, and in some apps you might want to have an unequal ratio between the two panes, and that's also possible using the two-pane layout component. So you would use this custom weight modifier attribute. If you've used rows or columns in Compose, it's pretty similar to that. And then you can set up a different ratio that's not just 50-50 between the panes. So this code snippet shows how you could set up a 70-30 split between panes 1 and 2. So using two-pane layout and dynamically switching the navigation components based on the app's width, these would be examples of more involved enhancements. So we've graduated from doing our static stretches. Maybe we're going to the gym 2 to 3 times a week. We're getting better here. And moving on to our final sample, this is our most complex one. It's a fictitious guitar sales app. So you can look on a map to browse for guitar stores, look through a catalog, and place fake guitar orders. And in addition to being available on GitHub, this sample is also available on the Play Store. So if you're going to check out any of the samples that we've shown today, I would recommend this be the one. This is really our favorite sample to show developers how to take advantage of the foldable form factor. So it uses all 5 of the design patterns we introduced. If we look here on the animation, at the start, we're using that list detail pattern from the previous sample. So you can see we have this list of guitars we can scroll through on the left, and then on the right, we have the detail view for the selected guitar. When we go to customize the guitar, however, we switch to the companion pane pattern, in which the secondary pane is used to display tools or other supplementary information. And this is great for gaming, editing, and drawing apps. And in our sample, we're using it to control the color and the body shape for the selected guitar. The implementation for this sample, we used both Views and Compose, and we're using a lot of our fold-aware UI components that are part of our Microsoft libraries. All of these components were built using information from the Jetpack Window Manager library. So this time for the deep dive, instead of showing you how to use our components, I'll show you how we use the Jetpack Window Manager library inside our component code to set everything up. But if you are more curious about how these components work and how to use them in your code, there's a really cool feature in this sample. If you see in the top right, there's something called dev mode for each screen, and you can click on that to show you the code for the SDK components that are being used, the current design pattern for the screen, and anything else you might want to learn about the implementation. So let's take a look at Jetpack Window Manager. So with this library, you can access 2 main categories of information. First, window metrics, or the size of the current window. And this is great, especially for large screen support, to set up different layouts depending on the window size. But you can also look at display feature or folding feature information with this library, which is what we're going to focus on today. In order to set this up in your application, the recommended way to do this is in your activity to use a lifecycle-aware coroutine to collect data in the form of a window layout info object. So if we look in the code snippet, we're calling collect here on a window layout info flow, and then inside these inner brackets is where we're going to add our logic to use this window layout info information. So if we go into this on window layout info changed method, you can see we have access to this window layout info object that has this display features property. So from this list of display features, you will try to extract a folding feature, and if one exists and it's not null, then you can use this folding feature and check its properties to make decisions about your layout. But what properties do folding features have? Well, there are quite a few. You can have state, which describes how folded a device is, so it can be either flat or half opened. You can have orientation, pretty self-explanatory, whether it runs either vertically or horizontally. Occlusion type tells you whether a folding feature hides content or if it doesn't. And then we have this final property called is separating, which is what I would really like to focus on today. This will return true when a screen can be thought of as having 2 distinct areas. So if separating returns true, that would be a case where you would want to start incorporating those design patterns that we mentioned or some of those other improvements to the user experience. And if we look on this next slide, you can see that the reason we really recommend using is separating is that it helps you support behavior for all foldable devices. So on dual screen devices like the Surface Duo, is separating will return true as long as an app is spanned across both screens. So again, going back to the definition of the property, that would be a case when the screen can be thought of as having 2 distinct areas. But on other foldable devices that have flexible displays, it will only return true when they are folded, so they're half opened. And again, you would think of that as having like a division between the 2 screens, so it would be 2 distinct areas. And then the property will return false on dual screen devices when an app is unspanned, meaning it's only shown on one screen, and on flexible displays, it will be false when the device is completely flat. So at that point, you would think of it as a normal small screen device or a large screen, depending on the size of the device there. So you can see how, instead of just checking for the presence of a folding feature or checking the state of a folding feature, using this is separating property kind of combines all of that logic into one, and it's a lot easier to set up your layouts with this. So now you know a little bit more about Jetpack Window Manager, and you're ready to start building your own custom components and updating your apps. So like this third sample that we just saw, your app should be ready to run a marathon, and they're in great shape. Next, I'll hand it over to Parker to talk about how to test your app's flexibility.
Thanks for the intro, Kristen. So what happens if you have a device, or like you have your app, you're planning on accounting for foldables, you're ready, you've done the code. What happens if you don't have a device to test on? Or maybe you have one device to test on, but you don't have the budget for every single configuration, every single device that you need. Instead, what you can do is you can use foldable emulators. There are some emulators available. Some are on Android Studio and others are available on the web that you can download that have specific virtual sensors that let you play with the fold itself. So on the left, we have a standard 7.6-inch foldable emulator that's available on Android Studio, and this lets you rotate from 0 to 180 degrees. This is common for like the Galaxy Fold or something where you have the screen on the outside, but also on the inside. And then on the right, we have the Surface Duo 2 emulator, and this folds from 0 to 360 degrees and lets you test the full range of motion, some additional spanning features, some additional orientations, and is really helpful for incrementally testing your app as you account for foldables without having to have the budget for a device. In addition to foldables, there are also emulators and virtual devices available for large screens. One thing you might not expect is on the left, we have a Windows subsystem for Android, and this lets you run Android apps directly on Windows 11, which lets you take advantage of the resizing of the window screen so that you can see as you drag the window how your app might react to different configuration changes, different window size changes, and kind of gives you an idea of, okay, I think maybe I want it to be in this shape. Let me test it to see what it looks like. And then additionally, straight out of Android Studio, we also have the resizable emulator. And this doesn't give as much freedom, but gives you a couple different options that are popular for different app sizes. So there's regular single screen phone, unfolded foldable device, then a tablet and a desktop window size, so that as you're testing your app, you can quickly switch through and see what it might look like in all of those different configurations. Okay, so now that we have a device, we're good. We're ready to actually start some tests. What kind of tools can we use to actually make those tests in Android? Well, there are a couple common different tools that we can use that are standard in any normal single screen test that can also be applied to foldables. So the tools that we'll cover can be used in single screen tests and can be applied towards dual screen, large screen, and other situations like that. The first that I'm going to talk about is UI Automator. So UI Automator lets you simulate user input, like taps and swipes and other gestures like that. But what we use it for on Surface Duo is actually simulating a swipe so that we can span the screen. So we have an app on a single screen, we span it over the hinge, and then it fills the screen into dual. So we can use UI Automator to simulate that action so that when a user is testing or a developer is testing, you don't have to span it across every time. Jetpack Window Manager, as Kristen was talking about earlier, has a lot of good features for detecting if there's a foldable feature, if there's a hinge, what are some of the properties for that. And there's a testing artifact that lets you simulate that. So you can inject that information into your test so that when you're running it, you can kind of use whatever emulator, whatever device you want. And we'll go over some of the details with that specifically. And then the Microsoft Test Kit is something that our team has been working on personally, and we've been taking some of the tools that I mentioned, in addition to Espresso and Jetpack Compose, in order to take all of the things that can work on single screens and actually format them in a way that works for foldables. And like you can do it for foldables with the normal approaches, but with the test kit, it's a single line syntax. It's a lot simpler. It's a lot more reduced and easy to use. And we will cover different ways that you can implement test kit into your tests in the future. So first, let's go over a general testing methodology so everybody's familiar with the structure we're going to use. We'll use the same fitness analogy. So first, when you're making your test, you're getting into a base position, you're setting your environment. Maybe you have a nice mat that you've rolled onto the floor and you're getting ready to stretch. And this is establishing what your testing environment is at the beginning. Next is an optional action. So once you're ready, moving, isolating a specific muscle, or for example in code, isolating a method or function that you're going to test and see how it works under stress. And then while you're going throughout all of these tests, making sure that if there are any pain points, you stop, you evaluate, and make sure that you know what's going wrong throughout those tests. So let's take a look at a basic test, just to get everybody familiar with the syntax. We'll look at a single screen test first. And for here, we're using Espresso. So what we're doing is we're setting up our test rule. And this is what we're going to do throughout all of the tests. We set up our test rule before it actually starts, so that once we actually get to the test, we can evaluate to see if what is displayed is actually expected. Here, we're using Espresso to evaluate a view, but it also has other functions for like testing intents and web views and other stuff like that too. The same thing that we're doing in Espresso can also be done in Jetpack Compose. Here we're defining a composable rule instead, but it's the same setup. And then instead of the Espresso syntax, we use some composable syntax instead to verify that the pane that we're looking for is actually being displayed. Everything that we're showing in the code can be done in Espresso and Jetpack Compose, but for just your sanity's sake of trying to keep the syntax straight, we'll be using Espresso throughout the rest of the code samples. So for UI Automator, let's dig into it a bit more and see what it can do for us, especially with foldables and large screens. So as I mentioned, UI Automator can be used to simulate user actions, user input, like taps and swipes. And so here on the screen, you can see that we're using it in order to span. So what we're doing is we're defining a start coordinate and then activating the swipe action so that we can locate the hinge and then drop it and span it across. Then for our testing sake, after that swipe action completes, we'll check to make sure that the panes display on both sides. So if we look into the code, it's the same thing at the beginning where we have a setup, but in this time, what we're doing is we're defining a device that we want to act on. And this is important because what we're going to do is we're going to inject that swipe action into the device itself. So we have our start coordinates at the beginning, end coordinates, and then the duration that we want it to move over. Once we've completed our action, we verify that both pane 1 and pane 2 are displayed. Say, for whatever reason, when we span across, it just drops on the second screen and doesn't span or stays on the first screen, then we'll know and we're able to verify that something went wrong. Now, I'm sure all the developers in the room are like, what's going on? There's a bunch of magic numbers. Something's not right. And that's what we have our test kit for. The test kit helps abstract some of the details, so you don't need to know the specific coordinates of the device that you're working on in order to actually perform the action that you want. And then additionally, if you make the same call, like the same span action across multiple tests, and then something changes, you don't need to change the coordinates every time, you just need to update the library. So it helps abstract a lot of the details with spanning and unspanning, as well as simulating some folding features and some Jetpack Window Manager stuff that we'll talk about. Another thing that's helpful is test annotations, and that lets you actually define before the test even starts, hey, I just want to be spanned. And then that way you don't have to perform an action, and it really helps isolate the function that you want to test while you're testing it. The test kit is open source. We've had some really great contributions from the community, and we're constantly updating it and making changes to make it the best that we can. So let's take a look at that same test that we had in UI Automator, but with test kit instead. So we have the same setup, and then once we get to the action, when we start the test, instead of defining the coordinates, all we have to do is say span from start. So our window was in the left pane, And we span from the start over the hinge, and then it span and goes over. We have some stuff under the hood that's able to detect what device we're testing on. So if it's not a Surface Duo or something like that, it will account for that in order to get it to a full screen orientation. And then we have the same pane 1 and pane 2 check to make sure that the test passes and we're doing what we expect to. All right, so let's dig into some Jetpack Window Manager testing in order to see what it's like in order to simulate a fold on maybe some emulators and devices that don't have a hinge. So the Jetpack Window Manager lets you test for foldables and folding features, and the testing artifact lets you simulate those. And as you noticed, we have a single screen phone and a large screen tablet, and both of those have a hinge down the middle. And what we're doing is we're just simulating it, telling the device that there's a hinge there that it should worry about. It can be used on any device, including actual foldable devices. And it's really helpful for testing on different configurations that maybe you think your app will be common on. So let's take a look at what it looks like to actually create a test. We'll just cover the test kit. There's a lot of boilerplate involved with actually setting it up in a non-test kit environment, so we'll just show you the simplified version. So first we define our test rule, some other publisher rules and things that we need to get started, setting our exercise mat down. And then once we actually start the test, our action is injecting that folding feature into the app itself, or into the test itself. After that, the app will react to that and we'll check to make sure that pane 1 and pane 2 are displayed, that it reacted to the folding feature being added, and that everything acted correctly. And one thing that we've commonly heard is like, why would we need to have like UI Automator and the simulating folding feature? Like, can't we just have one or the other because it gets to the same point at the end? And depending on what your use case is, you might need to use something different. For example, simulating a folding feature under the hood with TestKit actually differs depending on what device you're using. For Surface Duo specifically, we actually use a span across in order to get there. But for some other devices like Galaxy Fold or some other foldable devices or large screens, you don't have that spanning gesture and you just need to simulate a fold. So having both of those tools available really helps to make sure that you can account for all different devices and configurations while you're testing. So now that you know how to actually simulate a device, you have an action that lets you get to that point where you can get to a dual screen system configuration on your device while you're testing. What happens if you just want to start there? You just want to be like, okay, I'm running a test, I want the test to be dual screen. That's what test annotations are for. So let's take a look at the code to see what it looks like. So first we have our test rule. We define everything at the beginning, same as everything else that we've done. But instead, when we actually get to the test, we don't have an action. All we do is at the start just define, we want this to be a dual screen test. And then we're also adding an additional clause that says we want the rotation to be 0 degrees. We want it to be freezed so that if we input anything, it's not rotating the device. So that once we actually get to the test, all we have to do is check to make sure that it spans. We don't need to do any actions, or if we want to, we can define a different action to test instead. And that way we're really isolating the thing under test, making sure that we don't have too many running functions, too many things moving in the test itself. In conclusion, it's not super hard to get started changing your app to account for foldables. You can pull in simple things, low-hanging fruit, in order to get started with different foldable concepts. Maybe you incorporate drag and drop, or you incorporate like a simple extended canvas to account for a hinge down the middle. There are super easy ways to get started and test your app along the way. As you get more comfortable with that, you can refine your skills. You can maybe incorporate some design patterns and get some libraries in there that help enhance your app and make it look even better when you're on a foldable device. And then throughout, you have different emulators and different virtual devices that you can use to verify that your app looks correctly, to make sure that you're not just randomly guessing while you're making these changes on your device. We have some resources. Don't expect you to memorize these. Feel free to take a picture if you want. We'll also have these resources at our booth, so feel free to take a look. There's some interesting things that we think you should take a look at. We have a code lab that we've developed with Google, which we've helped incorporate some knowledge for foldables and getting started on a simple sample. And then also links to our emulator. We also have a Surface Duo blog where we post regularly. Every week we post on just stuff that we've updated, stuff that we think is cool, and you should definitely check it out. And then we also have a Twitch and a Twitter where we post updates and cool foldable stuff. Thank you so much. If there are any questions, feel free to either ask now. We have a mic over here, but also visit our booth. We have Surface Duo devices at the booth where you can come download your app from Google Play, see what it looks like. We've already had one person come and realize that their blog didn't look as they expected on a Surface Duo device, so please come check it out. I would really recommend it. But yeah, if anybody has any questions, we're happy to answer them. Thank you so much.